The DevOps revolution has changed the way we build and deploy software. Automated builds, extensible publishing pipelines, and configurable code that's easily shippable is the way to go. You no longer have to fret about complex software deployments or configurations anymore. With DevOps, you have the solution at your fingertips. Having said that, how do you go about implementing sturdy deployments which can be maintained just like any source code? How do you create a solid code configuration structure that doesn't fail? But if it does, you can easily debug it. How do you ensure that your development builds are secure and error-free? How do you realize the goal of building and delivering high-quality applications? Jenkins helps you answer these questions and more. Jenkins is a leading open-source automation tool that delivers what it promises. With Jenkins, you can implement continuous integration, create and automate pipelines for development, and achieve maximum positive results with minimum human intervention. With its vast pool of plugins, it can efficiently interact with third-party tools to achieve exactly what you want. Jenkins provides a host of features using which you can automate deployments on the go. But recently, a new paradigm shift has made Jenkins platform even more powerful. And that's called infrastructure as code. Basically what it means is that you can implement your CICD pipelines just like any other source code. With the Jenkins Domain Specific Language or DSL plugin, you can easily define jobs in an easy-to-code programming level. These code-based Jenkins jobs are identical to the usual Jenkins jobs. DSL jobs are written in simple Groovy. You have complete control of the job because you can configure and execute the code as required. You can access the GitHub repository to explore the features of the plugin and view a variety of build and test jobs. You can use the Jenkins Job DSL Playground if you'd like to test and review codes. With all this and more, the plugin offers quick job configurations on Jenkins. Wouldn't you want to know how you can make a difference in the world of DevOps automation? Step up for success and enroll for the Introduction to DevOps with Jenkins Pipelines and Groovy DSLs course today. My name is Arsh. I'm an instructor at tetratutorials.com. With an experience of over 2 decades in the software industry, we have been a part of many prominent projects and startups. This experience has given us a good insight into what makes for scalable, flexible, and strong software solutions, and we are passionate about sharing our knowledge in this field with you. In this course, you'll be introduced to a very powerful framework called Jenkins DSL. You'll learn how to code, configure, and deploy jobs in code form. You'll also explore Java application deployments with the plugin. With engaging demos, you'll get a front row seat to Jenkins DSL deployments. There is a rising demand for expert DevOps players in the software development game today. Innovation is the need of the hour, and you can hone your skills to create a niche for yourself. This course will help you build your credibility and become an expert DevOps engineer. After all, it's great to know what all you can achieve with Jenkins, right? Intrigued? With knowledge at your fingertips, you don't have to wait any longer. Imagine getting that promotion in your current role that your boss has been promising for months or years or ever since George Bush was in office. Imagine getting chased by recruiters looking for skilled and experienced engineers which companies are desperately seeking to hire. Employers are hungry for DevOps skills, and you could start looking like a big piece of pizza. Imagine getting a massive bump in your income as a result of your newly acquired in-demand skills. Not only will you look like a pizza, you'll also be able to afford a lot more too. That's what we want for you, and we know that's what you want for yourself. So to jumpstart your journey, just click on Enroll Now button below the video. The money and time you invest with us will not only boost up your career, but it'll also pay you many folds in just no time. You're still not sure? Don't worry. The course comes absolutely free of cost. No cash, no credit card, and definitely no Bitcoin required. So what are you waiting for? Let's get learning. Hello everybody, welcome to this short course on Jenkins DSLs. As you all know, software companies are constantly innovating development strategies to keep up with the growing demands of, technology. They look for consistent solutions to increase stability, quality, and profits. With DevOps and its continuous integration and continuous delivery principles, companies have witnessed exponential business and technological growth. Software enterprises that implement the CICD strategy in their day-to-day development gain higher profits and an edge over others. They're able to display their scale of innovation and growth in the field of technology. Jenkins is a tool that underlines the significance of continuous integration and delivery in software development. Jenkins is a vast, highly efficient automation platform. You can accomplish a lot with Jenkins, and it requires minimal configuration. A dynamic, stable tool that gives you the freedom to explore and automate a wide variety of tasks. With the entire process automated, human intervention is minimal, risks are low, and the product is delivered on time. Jenkins also provides you with features and plugins using which you can configure the entire deployment process as code. Jenkins DSLs are the backbone of the configuration as code advantage. In this module, you're going to learn how you can use Jenkins in your deployment process and optimize job configurations. Here are the high-level learning objectives of this course. We will look at a brief overview of the continuous integration and continuous delivery principles that power the DevOps strategy. We'll begin with an introductory module of Jenkins at a glance, a peek into the world of automated deployments with Jenkins. We'll also look at a few practical benefits of Jenkins as an automation tool. Next up, we'll take a look at Jenkins DSLs and learn how to use this plugin to create efficient and robust jobs. And finally, we'll learn how to, install and configure Jenkins. In light of the course overview, what can you expect to take away from this course? By the end of this course, you'll be able to define the principles of the DevOps strategy, continuous integration, and continuous delivery. Understand the basics of the Jenkins architecture and its role in automated deployment. Explain the significance of DSLs in Jenkins and how they can be utilized in projects. Utilize Jenkins and Jenkins DSLs in your day-to-day deployment projects to achieve highly effective results. Implementing Jenkins not only saves your time on tight deadlines for deployments, but it also changes the scenery of automation in a vastly competitive industry. Let's get going. Now let's see why you should learn about Jenkins and its vast array of features. Jenkins is one of the leading automation tools in the digital industry. It's an open source continuous integration platform written in Java. Jenkins makes it possible to practically apply the DevOps strategy to software deployments with continuous code integration, test executions, and product release. You can easily configure Jenkins to suit your automation needs by including steps for building, documenting, testing, packaging, and deploying. While working on the development of a software, the team commits the code into an integrated source code repository such as SVN or Git. The code is constantly updated by various team members. The Jenkins server checks the repository regularly and picks up the code as soon as a change is committed. This way, developers do not have to manually update the Jenkins server every time the code is committed. Jenkins helps reduce dependencies by implementing automation in every step of the deployment process. Jenkins pulls in the commits from the repository, creates an automated build, and runs it on a configured server. While this is happening, Jenkins keeps the developers informed of any failures or errors along the way. They're constantly updated on the status of the entire build process. Jenkins then proceeds to deploy successful builds for testing. Again, human intervention is almost nil. Developers enter the scene only in case of failures. Once testing is complete, Jenkins provides clear test results. Jenkins follows a reiterative build pipeline process, where every time a change is committed into the repository, Jenkins immediately picks it up and gets to work. A new build is created and deployed, followed by testing and final results. Jenkins' flexibility allows it to fit in a variety of environments, and it can help streamline the development process. This way, Jenkins enhances the development process with continuous integration of automated processes. This results in fewer integration issues and faster deployment. With Jenkins, it's not only possible, but also very easy to configure processes for continuous integration of the deployment pipeline. You no longer have to wait till each step of the process is complete in order to move to the next. The stage is set for end-to-end automated deployment. You receive constant feedback throughout the process, and this helps in faster bug fixing. Continuous testing ensures that the code is merged only once all tests have passed. As a result, the code is crisper, development is quicker, and the software quality is better. Jenkins' automated notification system is especially beneficial in critical development scenarios. Projects with competitive deadlines rely on Jenkins to ensure continuous development and no downtime. This saves on organizational revenue. With such configurations, you can launch large-scale deployments that meet growing market demands. And as a result, you optimize integration costs and build a more successful business. Although Jenkins is highly effective when dealing with large-scale builds, you may face situations where you have to handle a large deployment workload. There may also be requirements to configure multiple environments for testing purposes. In such cases, a single Jenkins server may not be able to handle the huge build and testing workload. To address such issues, Jenkins introduced a distributed architecture. In this model, you can deploy a master Jenkins server, which coordinates the build activities. To scale the build infrastructure, you deploy a cluster of slave Jenkins machines, which will actually execute the build operations in a scalable manner. With such an efficient system of distributed workloads, Jenkins ensures that there is absolutely no hitch in the deployment process. Jenkins has a vast and active community behind it, which is actively working on adding new features to it. Jenkins also offers a vast pool of plugins using which you can customize your deployment process across multiple platforms. You can also create new plugins on Jenkins. The elegance of Jenkins lies in how it can provide vast amount of functionality using this plugin ecosystem. And since Jenkins is a widely used tool, there is ample support from the online communities of agile and automation enthusiasts. There are many companies today that use Jenkins to fulfill their continuous integration needs. With its many benefits like easy configuration, vast plugin pool, open source integrations, and build automation features, Jenkins is the preferred choice among them. Let's take a look at a few of these big players. Industry leaders like Netflix, Facebook, LinkedIn, and Chartio rely on Jenkins to optimize their continuous integration pipeline. And many such world-leading players use Jenkins on a large scale to accelerate business performance. This is proof enough that Jenkins is a trendsetter in the field of DevOps and automation. Before we get going, let's talk about some housekeeping items. To download all the resources used in this course, please navigate to http://go.tetranoodle.com/Jenkins-DSL. Here you'll find the slides and other supplemental material for this course. So if you haven't done that already, please navigate to the URL listed above and download all the resources to your local machine. And once you've downloaded the slides for the course, you can review them from your local system even when you're offline. As you know by now, this course aims to equip you with the latest knowledge on the DevOps strategy by focusing on the CI and CD principles. The introductory module gives you an overview of Jenkins and its benefits in the automation pipeline. You'll learn the significance of Jenkins in achieving optimum results on deployment projects. Jenkins helps you achieve a lot in a given time frame without having to compromise on the quality of the process as well as the result. We hope you enjoy the information shared in this course and find it useful in your daily DevOps projects. See you in the next module. Hello everybody, welcome to this module, Getting Started with Jenkins and CICD. In the current module, you will look at the fundamental concepts of continuous integration and continuous delivery, and how they scale up automation practices in the software development field. You'll also be introduced to Jenkins and some other tools and frameworks which facilitate the implementation of CICD pipelines. Moreover, you'll also be introduced to Jenkins DSLs, which are used to optimize Jenkins jobs by writing configurations as code. The road ahead looks promising, so what are we waiting for? Let's get started. Let's see what you will learn in this module. We'll kick things off with a brief overview of the continuous integration, continuous delivery strategy that form the foundation for DevOps. Next, you'll learn about the high-level structure of a Jenkins job, outlining the lifecycle of job and the components used to accomplish each stage of the job. Next, you'll learn how to configure the prerequisites required for Jenkins. Once the prerequisites are in place, you'll learn how to install Jenkins. And finally, you'll learn how to configure Jenkins and customize it via the web UI. Let's begin. Before we dive into a discussion about Jenkins, let's first understand some key terms. The practice of automatically building your code periodically is called continuous integration. The resulting binaries after building the code can also be deployed automatically to the target environment, and this practice is called continuous delivery or continuous deployment. To paraphrase, Wikipedia defines continuous integration, or CI, as the practice in software engineering of merging all developer working copies to a shared mainline several times a day. Now let's see how it works in practice. During the course of regular software development lifecycle, one or more team members check in their code regularly into a source version control system or repository like Git, Subversion, etc. The CI server then fetches these fresh changes and integrates them. It then runs the build processes and produces a bundle of software build artifacts, and these artifacts are then versioned and stored in a build repository. The CI server then runs several automated tests like unit tests, integration tests, and so on to validate the build artifacts. The CI service may also send notifications to the team about the success or failure of this CI run. The CI server can run this entire process many times a day based on several triggers, for instance, upon every check-in of new source code from any developer or on a periodic basis. With continuous integration, you can confidently manage your software deployment because the automation server immediately spots errors and bugs and alerts the team. With on-the-spot issues brought to your notice, you can fix them on the fly and ensure the process continues smoothly. You can also configure multiple builds that can run in parallel. With this support, you can split the build and test processes over multiple virtual environments. What do you accomplish? An end-to-end deployment pipeline in a shorter duration. The practice of CI makes it easy to use the latest code version for deployment. With the benefits of code check-ins, fixes, and executions on the go, you are guaranteed a successful delivery pipeline for your product. There will be no more delays or manual errors in your software execution. With this advantage on your side, you can deploy sophisticated software without the fear of failure. You can also standardize the best practices in development and use them to create repeatable deployment processes. This not only offers efficient results, but it also saves on resources. Implementing the CI principle makes great business sense because you're in control of the build and delivery of your product, and you can save on resources such as time, cost, and effort. Continuous delivery, or CD, as a software engineering approach is one in which teams produce software in short cycles, ensuring that the software can be reliably released at any time. It aims at building, testing, and releasing software faster and more frequently. Let's now get familiar with continuous delivery. The key to deploying top-notch software is to execute deployment and implement feedback immediately. With continuous delivery, you can configure features, fix bugs, implement updates, and move the software to delivery in a sustainable manner. The deployments are low risk, stable, and within timelines. Whether your product is high-end or small-scale, imparting continuous delivery in your development pipeline gives you the advantage of delivering on demand. You don't have to worry about precious time or resources spent on fixing bugs and updates, as the automated process takes care of all of that. Implementing this principle makes your deployment a cost-efficient process. How so, you may ask? Well, software requires periodic upgrades to its architecture. Over its lifetime, it makes sense to have a cost-effective automation strategy in place. This way, you can automate your deployment environment and save costs on a release cycle. Every execution in the deployment process gives you real-time feedback, whether it's code change, version control, test execution, or release. The automated process catches issues in each step and notifies your development team immediately. Higher level testing such as usability and performance testing gives you a clear picture of the quality of your product. With the continuous delivery approach, you can avoid rebuilding software from scratch every time something fails. With the iterative feedback and test executions, you can fix the software and release as required. Development teams are better able to work on such organized methods rather than going back to the drawing board. They can actively engage with the end users, learn as they build, and be up to date with the functioning of the product. They're able to put their energy to better use on the fundamental parts of development and leave the drudgery to automation. This increases efficiency and boosts team productivity. And that is what businesses thrive on. Let's now understand the high-level structure of a Jenkins job. You begin by logging into Jenkins, creating a new job on the Jenkins dashboard. Next, you specify the source code repository from which you can pull the code for automation, such as SVN or Git. Then you specify triggers for this job. Once you set up the SCM for the job, you have to inform Jenkins when to kick off an automation build. There are 3 options to choose from: start a build once another build is complete, kick off build at intervals, or pull the SCM for code changes and trigger a build. You can configure any of these build triggers as per your requirements. Next, you can specify the build steps for the automation job, such as code compiling, cleaning, testing, installation, and so on. You can use build tools such as Maven and Gradle to configure jobs in Jenkins. You'll learn more about these tools as you progress through the course. Lastly, you configure the post-build actions for the job, such as send status reports, notify teams via emails, create post-build logs, archive artifacts, and so on. Configuring jobs on Jenkins is designed to minimize human intervention in the execution process, reduce errors, and optimize development time with automated builds. Of course, you'll learn about the Jenkins job structure in detail with the help of demonstrations later in this course. The main Jenkins server in this distributed architecture is the master server. The master's job is to pull the SCM repositories, which could be anything from Git to Subversion to CVS and others, schedule build jobs, dispatch builds to the slaves for the actual execution, monitor the slaves, possibly taking them online and offline as required, and record and present the build results. So primarily, the master's job is to orchestrate the builds and jobs across the whole cluster. That being said, a master instance of Jenkins can also execute build jobs directly, whereas a slave Jenkins instance is a Java executable that runs on a remote machine. The slave Jenkins instances accept requests from the Jenkins master instance and execute the job and report back to the master with the status. Slaves can run on a variety of operating systems. You can configure a project to always run on a particular slave machine or a certain type of slave machine, or simply let Jenkins pick the next available slave. For example, in this diagram, you can see that the Jenkins architecture consists of a Jenkins master, which is managing 2 Jenkins slaves. The Jenkins master distributes the workload to the slaves, which accepts the requests given by the master. Additional slave nodes can also be added to this architecture as the load on the system grows. Although it is easy to configure and set up a Jenkins job through the user interface, it's quite cumbersome to configure, manage, and maintain large jobs. This could get unwieldy even if you have simple jobs, but you end up accumulating a lot of them over the course of a project. You may also be able to copy configurations from previous jobs on Jenkins. However, this also takes up time and effort, and you may face a lot of issues like spending time on manually editing the copied jobs, configuring a large number of jobs, configuring jobs for multiple environments, mistakes or errors in manual configuration steps, and many more hurdles. There has to be a way to optimize this process, right? Yes, and there is. The best way is to configure jobs as code. With the help of DSLs in Jenkins, you can easily configure code to run automated jobs and reuse them whenever required. In our demos, we will be using Ubuntu. The core procedures and steps described in the upcoming demos will apply to other platforms as well. Before you begin the actual configuration process for Jenkins, you must have the latest version of the Java application in place. There are some prerequisites that you need to install for the whole setup to work. Let's see what they are. First, you need to add the Java repository to the automation server's package repository list where you wish to install Jenkins. Next, update all the packages installed on the server. You can then run the installer for Oracle Java version 8. This will easily install the Java application on the server. And finally, you can check the version of the Java application that is installed on the server. So let's get going. In this demonstration, you will configure the prerequisites for Jenkins on a Ubuntu server. Let's switch over to test the Ubuntu server. In this case, we have deployed a virtual machine for installing and configuring the Jenkins server. In your environment, you can use any suitable operating system and a virtual or physical machine to carry out these steps and install your own Jenkins server and follow along. The very first prerequisite that you need to install is Java. You can use the apt-get package manager in Ubuntu to install the latest version of Java easily. You'll need to explicitly install a Java runtime environment because Jenkins does not work with Java 9. So this is the safest way to ensure your system ends up properly configured. Adding an explicit dependency requirement on Java could force installation of undesired versions of the JVM. Before installing the package, let's make sure the Java package repository is configured in the personal package archive for Ubuntu. Let's begin by adding the Java repository to the PPA. Personal package archives include unsupported packages and are untrusted by the primary Ubuntu branch. At the time of publication, the Web Upt 8 Oracle Java PPA is just an installer, meaning it doesn't include any Oracle Java binaries, but it'll download and install them. On the command line terminal of the Ubuntu server, execute the command apt-get-repository ppa:/web upd8 team/Java. This command will add the Java repository from the personal package archive for Ubuntu. So run the command. You can see that the Java repository has been added to the server. Next, let's update the apt packages on the Ubuntu server. Let's clear the screen to give ourselves more room and execute the command apt get update and wait for the packages to be updated. And it's always a good idea to update all the packages before installing a major component or server like Jenkins. This ensures that there aren't version or dependency conflicts. Let's wait for the package update to complete. Okay, great. So the packages have been successfully updated on the Jenkins server. Next, let's run the installer for Oracle Java version 8. Let's clear the terminal, and on a new line, execute the command apt get install Oracle Java 8 installer. This installer installs the Java application on the server. It'll download all the dependencies required for Java and install them on the server. And you can see the list of packages that will be installed. Additional disk space is required to install this package, of course. To agree, type Y and run it. This is the license agreement screen. To use the Oracle Java Development Kit, you must agree to the license available on the site displayed here. Click OK. Next, you have to accept these license terms, Oracle Binary Code License Agreement for the Java SE, Platform Products, and Java FX. If you don't accept these terms, the installation process will be cancelled, so we have no choice, and to accept, we'll click Yes. The process unpacks the components of the Oracle Java 8 installer. You can view the progress of the download here. Let's wait for the process to finish. Okay, the download is complete. It proceeds to remove outdated cache downloads from the system and then moves to the installation steps. As you can see, Oracle Java 8 has been successfully installed on this server. It's now reading the database, unpacking the packages, and setting them up. Okay, great, the installation finished successfully. So after the installation is complete, let's verify the version of the installed Java runtime that was installed. Let's go ahead and clear this terminal. On a new line, execute the command java-version. And you can see the version displayed here, Java version 1.8.0.151. Okay, that's been installed on this server, and the prerequisites for Jenkins have been installed and configured, so let's keep moving. In this demonstration, you'll proceed with the next steps of downloading and installing Jenkins on the Ubuntu server. Now that the prerequisites are in place, let's move to the Jenkins installation. It's a quick process and it doesn't involve any complex configurations. In order to install Jenkins, you must first install some cryptographic keys. To keep things secure and explicit, Jenkins packages are signed with cryptographic keys. To ensure that the package is being downloaded from a known source, you need to download and install a public key on this Ubuntu server. In fact, we'll be using Google's Linux packages. Google's Linux packages are signed with GNU Privacy Guard or GPG keys. Google's packages will automatically configure your package manager to verify product updates with the public signing key, but you may also install it separately if, for instance, you want to verify the integrity of an initial package download. Follow the instructions to manually configure your package manager to use the keys. So let's begin. On the command line terminal on the Ubuntu server, execute the command wget-q https://dl.google.com/linux/linux_signing_key.pub pipe sudo apt-key add dash. This command includes the URL from which the package for adding a Linux signing key will be installed. You can see the result as OK, which means that the key was installed successfully on the server. Next, you need to add the location of the Jenkins package to the package manager list. Execute the command sh-c echo deb https://pkg.jenkins.io/debian-stable-binary /etc/apt/sources.list.d/jenkins.list. Now, after adding the package URL to the list, let's just ensure that it was configured correctly. So let's execute the cat command to view the updated list of package repository list. Okay, the list has been updated correctly, and so let's move on to the installation steps. Before installing Jenkins, let's run the apt-get update once again. So execute apt-get update. Okay, the packages have been updated. Now finally, let's use apt-get manager to install Jenkins. So execute the command apt-get install Jenkins. Press Y to proceed with the installation. And you can see that the installation is in progress. The operation downloads, installs, and configures the necessary packages for the Jenkins server. The procedure takes a few minutes to complete. After Jenkins is downloaded, it automatically moves to installing and setting it up on the machine. You can see that the Jenkins automation server is being set up. Okay, great. So Jenkins has been successfully installed and the Jenkins automation server is ready. Let's check the service status of Jenkins. So on a new line, let's execute the command service Jenkins status. And you can see that the correct version was installed and the Jenkins automation server is running with process ID 3704. In Linux and Unix-like environments, a PID or process ID is assigned to each process or instance when it's entered. So the Jenkins automation server has been installed and is ready to be configured via the web interface. You've seen how easy it is to download and install Jenkins. In this next demo, you will learn how to set up and configure Jenkins via the web interface. And you'll also learn how to manage plugins and customize Jenkins to suit your requirements. Now that you know how to download and install Jenkins on the server, let's see how to configure it via the web interface. You can easily tailor Jenkins to accomplish what you need in terms of automation builds. Let's open up a new browser window and navigate to the IP address or domain name of the server where you deployed your Jenkins server. Make sure you connect on the port 8080. When you access Jenkins for the first time using a web browser, it may take some time to initialize and load the configuration wizard screens. As you can see, the text on screen says that the browser will reload automatically when Jenkins is ready. So while Jenkins is getting ready, let's take the next steps quickly. Jenkins is a secure server, and it needs authenticated users to log in and work with it. To unlock Jenkins and get it running securely, you must provide a username and the default admin password to log in. You can access the admin password in the var lib secrets path on the server. So let's go back to the command line terminal and change the Active Directory to the Jenkins secrets path. Okay, now let's retrieve the admin password from this file called initial admin password by using the cat command. And here's the password. You can copy the password displayed here. Back to the browser window. Okay, the Jenkins server has initialized now. Here you are on the unlock Jenkins screen, which is asking for the initial admin password. So you can verify the path of the library from which to copy the password. Let's quickly switch back to the terminal window and copy the password. And now paste that password in the administrator password field, and then click continue. The system securely unlocks Jenkins and redirects you to the setup wizard. You can now customize Jenkins with its large pool of plugins, security management options, and user and system configurations. So let's move to Jenkins customization. This is the getting started page of Jenkins. Here you can choose to install the suggested plugins or select and install required plugins. Here you can install any number of useful plugins as part of your initial setup. Click one of the two options shown. Install suggested plugins to install the recommended set of plugins which are based on most common use cases. Select plugins to install to choose which set of plugins to initially install. When you first access the plugin selection page, the suggested plugins are selected by default. If you aren't sure what plugins you need, choose Install Suggested Plugins. You can install or remove additional Jenkins plugins at a later point in time via the Manage Jenkins, Manage Plugins page in Jenkins. Let's choose the first option, Install Suggested Plugins. These are the suggested Jenkins plugins being installed, such as folders, workspace cleanup, Gradle, email extension, and so on. The suggested plugins, curated by the Jenkins community, help to increase productivity of the tool. The setup wizard shows the progression of Jenkins being configured and your chosen set of Jenkins plugins being installed. So this process may take a few minutes. Okay, now all the plugins have been successfully installed. So next, let's enter the credentials to create the first admin user for Jenkins. Enter Jenkins in the username field, and enter a secure password in the password field, and repeat the password in the confirm password field. Next, let's enter the full name as Jenkins. Let's provide the email address as jenkins@tetra.com. Click Save and Finish to save these details and continue. Now that Jenkins has been set up and the user credentials have been provided, let's move to Managing Jenkins. Click the Start Using Jenkins button, and you're redirected to the Jenkins main dashboard. This is the central control panel for you to manage Jenkins and all the jobs, plugins, and so on. You can see various options on the left-hand side of the page, such as New Item to create new build jobs, Build History to view historical builds, Manage Jenkins to customize various features of Jenkins, and so on. Below that are the Build Queue and Build Executor status sections that will display the queued build and status of the executed builds. Let's click the Manage Jenkins option. You can view a list of options such as Configure System, Manage Plugins, Load Statistics, and more. Let's explore some of these features. Click the Manage Plugins option. This is the Plugin Manager. You can see the tabs here. The Updates tab displays updates made to currently used plugins. The Available tab displays the plugins available for download from the Configured Update Center. The Installed tab displays the plugins installed on the Jenkins server. And finally, the Advanced tab includes advanced plugin configurations. Since we're focused on Jenkins DSL in this course, that is one plugin you must install. Let's search for the Job DSL plugin. Go to the Available tab. In the Filter search field on the top right corner, enter Job DSL and click Enter. The search results show a list of available plugins related to the search, and you can see the Job DSL plugin on the screen here. Below the result, you can see two options for installation. You can install without restarting Jenkins or after restarting Jenkins. It's better to download the plugin and then restart Jenkins, so let's select the second option. You're redirected to the Installing Plugins or Upgrades page, where you can view the progress of the Job DSL plugin installation. At the bottom of this web page, check the Restart Jenkins checkbox. This option restarts Jenkins when installation is complete and there are no running or pending jobs. The installation is complete, Jenkins will restart and the plugin will be available for use. The Auto Refresh plugin from the Update Center checks the current status of the Jenkins process. And the reset is now complete. This is the login page. Let's enter the credentials that were created earlier, username and password. Click Login, and now you've logged into Jenkins. Let's explore some of the major features of Jenkins. Click the Back to Dashboard option on the left-hand pane here. You can create and configure new jobs here and view build information. Click the Manage Jenkins option, and you can see a list of configuration options here. Let's begin with Configure Global Security. After Jenkins is set up, anyone can log into Jenkins as a user. This could become a security issue, so to manage it, you can use this option to set up basic security for Jenkins. This feature allows you to set up two options. Firstly, set the security realm to determine who should have access, and secondly, set the authorization to determine what each user is allowed to do. Let's go back to the Manage Jenkins page. The next feature is Configure System. You can set up system-wide settings and paths in Jenkins. You can also define global parameters for installing Jenkins and other external tools for your builds. You can set up system messages and quiet periods for scheduling a specific time period before picking up code commits. Next, let's look at global tool configuration. In this section, you can easily configure various tools, locations, and installers that can utilize the time of creating a build job in Jenkins. As you can see, some of the build tools that you can configure are Maven, Ant, Gradle, and so on. So in this way, you can easily set up Jenkins and start working on your automation projects. That brings us to the end of this module. Let's have a quick recap of the topics covered, shall we? A brief overview of CICD. You went over the principles of DevOps, continuous integration, and continuous delivery. Then you got familiar with the Jenkins job structure, outlining the life cycle of a job. Then you got an introduction to Jenkins DSLs. In Jenkins, you can configure code for jobs in the form of a plugin. The Jenkins plugin is called Job DSL plugin. It's written in the Groovy script, which makes it easy for developers to define jobs in Jenkins. You viewed informative demos for installing Java as a prerequisite, followed by installing and configuring the Jenkins automation server and web interface. That's all we have for you in this module. Stay tuned for the next module where you will learn how to configure the Job DSL plugin in Jenkins. Hello everybody, welcome to this next module, Building Robust Jobs with Jenkins DSLs. Let's briefly recap the previous module. In the previous module, you were introduced to a few interesting concepts like DevOps and Jenkins. You learned about a few build tools such as Ant, Maven, and Gradle, which can be integrated with Jenkins and used to optimize the build and deployment processes. You became familiar with the prerequisites that were required to install Jenkins on the application server. With the prereqs in place, you saw how easy it was to install and configure Jenkins itself. Next, you saw how to install and configure Jenkins on the server. With the engaging demonstrations, you were able to view the application process of these features. This module is also going to be an interesting insight into what Jenkins has to offer. In this module, you will learn about the Jenkins DSL Playground, what it is, and what you can do with it. You will then learn how to use the Jenkins Job DSL plugin. As you know, this plugin is used to write configurations in the form of code. This enables the programmatic creation of jobs on Jenkins. The advantages of the Job DSL plugin are evident in job deployment, with quick turnaround time and more successful coding. Many Fortune 500 companies and government agencies focus on implementing configurations as code in their application deployments. They benefit with the DevOps implementation by adopting tactics for efficient deployments and quick failure recovery. As you proceed to view the demonstrations, you'll get a clear idea of the significance and use of this plugin. This is just the beginning of an exciting journey into the world of building configurations as code. Let's jump in. Let's see what you will learn in this module. First, you'll get an overview of the Jenkins Job DSL plugin. You'll also learn about the Groovy scripting language features of the Job DSL plugin, using which a job can be configured in Jenkins. Then, you'll be introduced to the Jenkins Job DSL Playground. Next, you'll get started by learning how to configure the Job DSL plugin. Once the plugin is installed and configured, you'll learn how to implement the plugin to configure a job on the Jenkins UI. You'll also learn how to use the Groovy features of the plugin while configuring the job. And then you'll view how to run the configured job. Next, you'll take a look at some useful DSLs which can help you create robust DSL scripts in Jenkins. And last but definitely not the least, you'll learn how to use these effective DSLs to simplify the job configuration processes and satisfy complex deployment needs in Jenkins. Let's go. As you know, jobs in Jenkins can be configured with the Job DSL plugin. It's a Groovy script-based plugin which enables developers to define jobs in Jenkins using conditional statements, variables, and loops. Essentially, the plugin comprises of two parts. One is the DSL itself, using which you can define jobs using a Groovy-based language, and the other is a plugin which manages the scripts and the Jenkins jobs that are created. Therefore, the plugin aims to minimize manual configurations by allowing jobs to be defined with minimum necessary programming and with the help of templates that can be synced with the existing jobs. Let's now take a look at some of the Groovy language features of the Job DSL plugin. The first feature is variables. In Groovy scripts, you can define a variable using the def or def keyword. You can use this keyword if you don't want to restrict the type of an object. You can save the variable in Jenkins for future use. Next, let's look at loops. You can configure this feature to repeat certain tasks a certain number of times. In order to create multiple similar Jenkins jobs, you can use the for loop to specify the number of times a job is to be created. You can also provide the necessary variables for this statement, such as defining the GitHub URL for checking out code. The next feature is called branch looping. This feature is useful when you want to execute several jobs in parallel. So in this instance, you can list out the variables or branches as an array and proceed with configuring the tasks and SCM for these branches. Once executed, the script performs the steps for each branch. This feature uses the def branches keyword. Lastly, let's look at functions. In Groovy scripting language, a function can be defined and assigned to a variable, thereby allowing it to be passed as a first-class object. For this feature too, you must provide a variable, which can be the name of the function, for example, create a Maven job. Here too, you must use the def keyword. You'll be able to better understand these features with examples in the upcoming demos. The DSL execution engine exposes several methods to create Jenkins jobs, views, folders, and config files. These methods imply the creation of a Jenkins item, and the closure to the method can be used to define the item settings. The only mandatory options is the item's name. For instance, there's a method to create or update a Jenkins job correctly called job, and it takes in the job name as a parameter. The plugin tries to provide DSL methods to cover common use cases scenarios as simple method calls. When these methods fail you, you can always generate the underlying XML yourself via the configure block. Sometimes a DSL method will provide a configure block of its own, which will set a good context to help modify a few fields. This gives native access to the job config XML, which is typically very straightforward to understand. By the way, the full XML can be found for any job, view, or folder by taking the Jenkins URL and appending the /config.xml to it. We find that creating a job the way you like it, then viewing the XML is the best way to learn what fields you need. Now, let's learn about the Jenkins Job DSL Playground. The Job DSL Playground is a web application using which you can test domain-specific configuration text with syntax highlighting. As you can see, this is a screenshot of the playground. You can enter the code in the text editor pane on the left-hand side. The right-hand pane shows the corresponding XML file generated with the code. The playground becomes especially handy when you don't have Jenkins installed on your machine, but would like to try out some hands-on job DSL configurations. Unlike the Jenkins API, wherein you have to enter and run the code end-to-end each time, the playground saves your time as you can inspect and improve your code instantly. And you can access the playground at job-dsl.herokuapp.com. There are a few benefits of using the Job DSL Playground. Firstly, you can test your scripts to check if they're written correctly. A well-written script returns immediate results. You can run snippets of code to check for improvements and make changes on the go. And there are no edit-save cycles on the playground. Therefore, fine-tuning your code is a lot faster. In this demonstration, let's explore the Jenkins environment and Job DSL plugin. This is the Jenkins dashboard that you have already reviewed in one of the previous demos, but here you can see we have created a bunch of test jobs which we will explore later in the upcoming sessions. So let's quickly check on the status of the DSL plugin that you installed in one of the prior sessions. Click Manage Jenkins. On the Manage Jenkins page, click the Manage Plugins option, and you'll be redirected to the Jenkins Plugin Manager. On this particular Jenkins instance, the Job DSL plugin has already been installed, so let's switch to the Install tab and search for the Job DSL plugin. To learn more about the plugin, click on the name of the plugin. It redirects you to the Jenkins wiki page of the Job DSL plugin. And here you can read about the plugin and take a look at some of the basic examples of DSLs using which you can create jobs on Jenkins. Okay, now that the plugin is in place, let's go ahead and create a Jenkins job to use this plugin. Okay, now it is time to meet the star of the course, the DSL plugin. In this demonstration, you will learn how to implement the Job DSL plugin with Jenkins. The implementation will be done in the following sequence. Create a job within the Jenkins UI, configure the Jenkins job, and implement the Groovy features of the Job DSL plugin into the Jenkins job. Now that the Job DSL plugin is installed, let's learn how to implement it. Let's begin by creating a job in the Jenkins UI. Navigate to the Jenkins dashboard. On the left-hand side, click New Item. Let's provide a name for the project, Bootstrap. It really doesn't matter what you call this job. You can provide a name for this job as per your preference, and this is going to be an empty test job. Below the item name field, you can view a list of project types. Click the Freestyle Project option. This option is used for general purpose build jobs. It provides maximum flexibility because Jenkins builds your project, combines the source code repository, runs tests, and conducts continuous or nightly builds. Click OK. A new project is successfully created on Jenkins. So this is a blank job using which you will learn how the Job DSL plugin can be utilized. Let's now see how to configure this job. This is the configuration section for the newly created job. In the General tab, you can see that the project name is Bootstrap. Next is the description field where you can provide a brief description about the project. Scroll down to the source code management section. You can select the source code repository from where you can pull the code for your project. For example, you can select the Git option. You can provide the details of the Git repository such as URL, credentials, and so on. Since this is an empty test job, we are not going to hook up any source code repository here. To use the Jenkins DSL plugin, scroll down to the Build section and select Process Job DSLs from the drop-down menu. Once you select this option, you can configure options such as adding Groovy scripts for the job. If you have readily available Groovy scripts in the repository, you can specify them in the DSL scripts section. You can specify multiple Groovy scripts, each one separated on a new line. The job has been configured, let's now test the groovy features of the plugin. As you can see on the screen, here's a list of examples of the groovy script snippets that we can configure for this job. You will view how these features work and how they can be used to configure the Jenkins job. Instead of running each feature in the Jenkins environment, let's access the Jenkins Job DSL Playground for quick code test runs. So in a new browser, navigate to the URL https://job-dsl.herokuapp.com. From the list of examples, let's pick the first example of the groovy feature, variables. By the way, these example scripts are available to you in the course resource download bundle. Please do download it to follow along. Copy the script for configuring variables and paste it into the text editor section of the Job DSL Playground. Here, the first line of the code defines a variable called job name. Let's enter the value for this variable as tetrajob in single quotes. On the next line, the script will call a standard DSL API function called job. This function creates or updates a freestyle job, and it takes in a parameter called job name. So basically, all this script is going to do is create a dummy Jenkins job called tetrajob. And to run the script, click Run. You can see that the execution has generated the XML for the script. It shows rules such as actions, description, properties, triggers, and so on. This means that the groovy script was a valid script without any errors and you were able to run it correctly. So you can see the Job DSL Playground shows you immediate results of your test script runs. Let's execute the same example of the Jenkins UI. Back in the Jenkins job configuration page, select None for source code management. Since you're learning how to execute the examples of the groovy features, there's no need to define a source code repository at the moment. Scroll down to the build section and select Use the provided DSL script. Since this is going to be the very first simple groovy script we will see, let's not save the script on the file system. Instead, you can write the script in line within this job. That being said, the real power of writing groovy scripts for Jenkins jobs could only be harnessed if you save your scripts on the file system and version control them, and also share the scripts amongst team members. However, for this simple example, select the option to use the provided DSL script. And with this option, you can directly enter the script for job configurations in Jenkins. Go to the Job DSL Playground and copy the script. Navigate back to the Jenkins UI and paste the script in the DSL script field. Click Save to save the changes. The Bootstrap job is now configured and it's ready for build. You'll be redirected to the homepage for your Jenkins job. In this case, the Bootstrap job. To kick off a fresh build for this job, on the left-hand pane, click Build Now. The build has started and you can see the process of the build in the Build History section below. Now, if you click on this blue circular icon, you can get to the detailed output log for this build run. And here it is. As you can see in the console output, the build for the job was successful. You can see the workspace where the job was built, followed by the build parameter that is provided by the DSL script, and the newly generated job with the name tetrajob. Let's get back to the Jenkins dashboard homepage. On the top left corner of the page, click Jenkins. You can see the list of jobs currently configured on this Jenkins instance, and you can see the tetrajob listed here. Let's click on this new job to get to the details. And here you can see the seed or parent job has been listed as Bootstrap. So you see how the parent Bootstrap job generated a brand new job, tetrajob, based on the DSL script you implemented in this job. That's a lot of uses of the word job, but I think you know what I mean. Okay, so this was a very simplistic The world of configurations as code is interesting and simple at the same time. So let's quickly have a module recap. A brief overview of the Jenkins Job DSL plugin. You learned about the Groovy features of the Job DSL plugin using which a job can be configured in Jenkins. An introduction to the Jenkins Job DSL Playground. You can use the Job DSL Playground to test DSL scripts and get real-time results. Unlike the Jenkins API, wherein you have to enter and run the code end-to-end each time, the Playground saves you time, as you can inspect and improve your code instantly. Jenkins Job DSL plugin. You learned how to install and configure the plugin on the Jenkins UI. Implementing the Job DSL plugin. You viewed demos on how to implement the plugin to configure a Jenkins job and use some of the Groovy features of the plugin such as variables, loops, branch looping, and functions. Alright, that's all it is to this module, folks. We hope this illustrative mini course has got your brain cells tickled. This is just a dip in the ocean of Jenkins configurations. There's an entire world of innovation and technology waiting just for you. Take your first step towards an exciting and educational journey. In the main course on Jenkins DSLs, you'll be able to view interesting and informative demonstrations. You'll have the opportunity to learn how the Jenkins DSL plugin can be used to deploy applications on the server. The use of the Job DSL plugin drastically reduces configuration time and has minimal human intervention in the deployment process. So what are you waiting for? Enroll today, arm yourself with knowledge, and see your career prospects rise.